Okay, hi. So here's a little video to help you solve inequalities, and we have one written up top. Negative 12 is greater than x minus 7. So to solve the inequality, we need to isolate x, and so we do that by taking away, in this case, the constant, which is negative 7. We're going to use the same value but the opposite operations. Okay? So if I have negative 7, I'm going to add 7 to both sides. Okay, just like solving an equation, what you do to one side, you do to the other side. So if I have negative 7 and I'm adding 7, those 7's cancel out and I'm left with x. Then I still have my greater than symbol. Negative 12 plus 7 is negative 5. Now, I have my inequality here that says that negative 5 is greater than x. So there's my negative 5. Now I know that negative 5 can't be equal to x because it's not greater than and equal to x, it's just greater than x. So which direction is my line going to go, to the left or to the right? Well, let's think about this. If negative 5 is greater than x, then that must mean that x is less than negative 5. Right? And we can even rewrite this. If you're uncomfortable with having the variable on the right, we can flip it around and write it like this. But like I just said, if negative 5 is greater than x, then x must be less than negative 5. And if you take a look at the symbols, you can see that the symbol, the open space of the symbol is pointing to the negative 5 in each case. Okay, so if x is less than negative 5, we are going to draw our arrow this way to show that x can be any value that is less than negative 5, up to and including negative 5.1 or negative 5.05 or whatever. Okay, so that's going to work for that one. That is our, just get rid of this. This is our solution, and then we have our graph below. Okay, let's try another one. And this time we will try this one right here. Negative 9x is greater than or equal to negative 90. Okay, now once again I want the x to be alone. Now let's take a really close look at what's happening here. Okay, negative 9x is a multiplication question. It is a product, okay? Negative 9 is being multiplied by x. So I need to do the opposite operation. And what's the opposite operation of multiplication? Division. So I'm going to divide by negative 9. Now, I also need to divide by negative 9 here. So negative 9x divided by negative 9 is x. Negative 90 divided by negative 9 is positive 10. However, when you divide or multiply an inequality by a negative, you have to flip the sign to its reverse. And the reasons why you might do this are a bit confusing, but first let's just graph this and then we'll get into the reason why. So x can be any number that is 10. So I'm going to color in the boundary point here to show that it can be 10, or it can be any number less than 10. So we're going to do that. Okay? Now, why did I flip the sign here? Well, let's go back to the original inequality. There it is. Now, what we have below here is telling us that any value that is 10 or less will make this statement true when we substitute for x. Okay? So let's try this out. Let's try using 10. So let's think this through. So if x is going to be 10, I'm going to end up with negative 9 times 10, which is negative 90. And negative 90 is greater than or equal to 90. So 10 works. Okay? Now let's try a value that is less than 10. So let's try 5. So what happens if we have a 5 here? Sorry. Yes, 5. So, negative 9 times 5, positive 5, is negative 45. And is negative 45 greater than or equal to negative 90? Yes, it is. So negative 5, or sorry, so 5 will also work. Okay? So any number in this section of this red section here will work. And that's why we had to turn this sign around. If I had left it as a greater than sign, and so if I had actually ended up with this, x is greater than or equal to 10, I would be saying that any of these numbers would also work, greater than 10. Well, let's try that out. Let's try 11 and see what happens. So if I substitute the x for 11, and then solve, negative 9 times 11 is negative 99. This statement is not true. Negative 99 is not greater or equal than negative 90. Negative 99 is less than negative 90. So this statement is not true. So, and that would be the same for any of these values that are greater than 10. So we have to turn, when we divide by a negative, we have to reverse the sign in order to come up with a solution set that will make the inequality true. So please don't forget that, okay? Hopefully this helps you, this little video helps you as you continue to do your work on one-step equations.